talk about energy, really they're talking about what we call exergy. Exergy is the high quality energy. It's available to do the work that we want actually accomplished, the transformation of that matter into the goods and services we've talked about. Once we use that exergy, it becomes waste. And what we call energy is really a combination of the high quality energy and the wasted energy. Together, that larger energy is unchanged. We have that high quality energy we can put to work, and then once that work is essentially done, it transforms either into goods and services or waste. It turns out that when we properly measure how the economy works, we're converting maybe at this point 14% of all the exergy, the high quality energy, into useful work. And that means we're wasting 86% of that energy. That waste creates environmental problems, it creates lost value that we're not able to recover to produce jobs and incomes for families and communities. So it becomes a critical issue if we want to really maintain the well-being of our economy. And that means we have to step back and measure it properly, which we're not doing right now. And that means we have to understand the fundamental elements of exergy as it powers the economy forward.
Not all energy forms are equal, because as we've seen is that some of the energy forms have a much higher ratio of exergy to energy. And typically electrical systems have a ratio that is very close to 1 in that form. And therefore electrical energy is a very good vector or energy carrier because it is a high carrier of exergy. And so what's interesting is that if you look at a lot of the renewables, they directly convert to electrical systems without going through a thermal process. So the electrical system that, the electrical energy that a PV cell makes is a very high form of exergy, and therefore has the ability to do work very readily. So for example, if you look at the exergy carried in a petrol-based car, you could see that typically 50 litres of petrol equates to something like 500 kilowatt hours. And if you think that's a lot of energy, it is. However, only about 5% of that energy is actually turned into useful work. When you look at something like an electric vehicle, it's carrying a lot less energy, only about, say, 30 kilowatt hours. But what we find is something like 75 to 80% of that energy gets turned into useful work. So therefore you can see that although the energy carrier looks like it's much smaller, it's producing much higher quality energy, enabling you to transform that into service much more readily and with a lot less wastage of energy in the process of doing so.